All right. Hello, everyone, and thank you so much for being here today. On behalf of the Environmental Finance Center Network, welcome to our webinar, PFAS Today, Tomorrow, Forever. MCLs are here. Now what? My name is Kristen Crew from the Syracuse University Environmental Finance Center. Before we begin, we're going to go over a few logistics and then we can get started. During the webinar today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it into the GoToWebinar question dialog box anytime throughout the session. We will be saving your questions for a facilitated Q&A session at the end of the presentation. After the webinar, you will receive a follow-up email that includes a link to the recording and other information that you may need. You can also download the slides from today in the Handouts tab in your GoToWebinar control panel. This webinar has not been submitted for pre-approval of continuing education credits, but eligible attendees will receive a certificate of attendance for their personal record. To receive a certificate for the session, you must attend for the entire session and register and attend individually using your real name and unique email address. Certificates will be sent via email within 30 days of the webinar date. If you have questions or if you need assistance, please contact smallsystems@syr.edu. Now for a little bit about us. The Environmental Finance Center Network provides training and technical assistance to small water and wastewater systems in all U.S. states and territories through our building technical, managerial, and finance capacity programs. If your community or your utility needs assistance with drinking water or wastewater system management, please feel free to contact us through our request form, which I will be sharing shortly in the chat. And before we begin, I'd like to quickly highlight a couple of upcoming webinars that EFCN is holding. We have a webinar on lift station operation and maintenance, as well as a webinar on wastewater collection systems, operations, maintenance, and inspection. I will be sharing the registration links to those in the chat shortly as well. All right, and on that note, we can go ahead and get started. I would like to introduce our presenter for today, Will Shaffer. Will is a senior project engineer at EEC Environmental. Welcome, Will. I will go ahead and pass it over to you, and I'm also going to start a poll that is asking folks what kind of role they are currently in.
All right. Yeah, thank you, Kristen. I'll take it from here, but we wanted to just kind of open this up with a poll to get a feel for who's out there in the audience today and what your role is, whether you're a state regulator, a primacy agency, a water or wastewater system operator or owner. Maybe you're an engineer or a consultant advising any or all of these. Or maybe you're someone else. Maybe you're just an interested individual wanting to learn a little bit about PFAS MCL compliance. So please take a minute to answer this poll. We'll share those results, and I'll kind of tailor my presentation based on who's out there today, talking a little bit more about one or multiple items that are on the agenda today. So please take a second to answer that poll. And Kristen, if you can share those results when they come in.
Yep, looks like most people have answered, so I'm going to close the poll in just a couple of seconds. Go ahead and get the answer in if you haven't already. All right, closing the poll in 3, 2, 1. All right, Will, so we've got a little bit of everything. We actually have mostly regulators in the audience today of 35%. We have 5% water, wastewater system owners, 17% water and wastewater system operators. We have 21% are engineers or consultants, and 22% are others. So
awesome.
With the range.
Great, yeah, good mix here today. A lot of on the regulatory side. That's awesome. Thank you for attending. And I'll be interested to hear from you guys as well in the Q&As. Please submit your questions as we go along. We'll have this kind of facilitated Q&A session at the end, but particularly on the regulatory side, what are your questions that you have around PFAS MCLs and what the primacy requirements are, how to enforce these MCLs, things like that. I'd love to kind of start that dialogue throughout the presentation and at the Q&A session at the end. So curious to hear what your questions are around these new final MCLs here for PFAS. So with that, let's dive right in. I'm gonna share my screen here. Kristen, give me just kind of a verbal confirmation. Let me make sure I'm sharing the right screen here.
That looks great.
All right, great. We'll dive right in. So like Kristen said, today we're talking about MCLs. MCLs are here, they're finalized. They've been adopted. And what do we do now? What do we do as system operators or owners? What are our monitoring reporting requirements? What do we do as primacy agencies? What do we do as the public? If we've got PFAS MCLs, what does that mean? What does it mean for public health, for water quality throughout the US? We're gonna dive into a little bit of all of that here today. So thanks for joining us. This is, again, another webinar in a series of webinars that we've been doing with the Environmental Finance Center Network called PFAS Today, Tomorrow, and Forever. So there are other webinars in this series. They're all on YouTube and on EFCN's website. Feel free to go look those up. Some of those are deeper dives into individual topics like treatment technologies, which we're not going to take a deep dive into today for time's sake, but there is a previous webinar that looks at those treatment technologies and a bit of a deeper dive into that. So if you're interested, please go back to EFCN's website, go look at those previous webinars, and those resources are there available for you. So with that, we're going to jump right in. Let me get the slides moving here. Like I said, we're going to start this as we do in all of these series with just a brief introduction into PFAS. There's probably a number of people online here today who know very little about PFAS, so we're not going to talk about everything about PFAS, but we'll give a kind of a baseline introduction on what it is and why it's important. We'll talk about the regulations around PFAS, what has been done by the EPA to date, and where are we headed. We'll look at UCMR 5 results, which I kind of like to just have a continual check-in. New data is dropped every quarter, so a new check-in into what those results are telling us nationwide as the PFAS picture nationally. We're going to talk about what the finalized MCLs are, drinking water MCLs for PFAS. We'll talk about what the requirements are based on those MCLs. We'll touch briefly on what that means for the wastewater sector, but that could be an entire another webinar, so we're not going to take a deep dive, but we'll talk about how MCLs are going to inform other regulations in the future. And then lastly, we'll touch on the funding options here. So with that, let's jump right in. A brief introduction into myself and EEC Environmental here. EEC, we're a national consultant. We're coast to coast, headquartered here in California, but we're coast to coast with the staff of chemists, engineers, geologists, hydrogeologists. We got a wide range of expertise here, and in all of those areas, we have PFAS experts, and we've been doing this for a number of years, advising clients and agencies and cities and industry on how PFAS is going to impact them, and now that we have finalized regulations, how it is impacting them. That's anything from site assessment and remediation. We'll talk about the CERCLA designation and how that impacts, phase 1 and phase 2 and site cleanup. PFAS characterization and planning, helping systems sample for PFAS and determine if they have a PFAS problem. And then if you do treatment system design, I'm a civil PE. That's my background as a civil engineer, civil and environmental engineer, utility design, treatment system design and build. And so we have that expertise to help those systems, and we're helping some of those systems, particularly here in Southern California, that are implementing PFAS treatment currently, have systems up and running that are already treating for PFAS and designing, constructing more PFAS treatment systems. That includes owner's rep positions and expert witness support in litigation as well. So if you have any of those needs, please feel free to reach out to us. With that, let's kind of lay the groundwork here. PFAS 101. Again, PFAS is this kind of umbrella term, right? It's per and polyfluoroalkyl substances, but it's this umbrella term for this broad range of fluorinated chemistry, fluorinated compounds that are widely used throughout consumer products. And you find them everywhere you look for them. They're old. They were developed in the 1940s and rolled out into large-scale manufacturing and in products like Teflon and Scotchgard and all these other products that were used extensively over the decades. So that's kind of the problem in a nutshell, is it's so ubiquitous, right? We find it in so many products that we've used that are useful throughout our history, but that presents a problem as those PFAS compounds then enter the environment. And how do we clean that up? Because they're found to have negative impacts on human health and the environment. Dark Waters, just I think last month, was put back on Netflix. And so this is kind of a, it's a movie from, I think, 2019. It's been around for a couple years, but it's getting renewed attention. That this movie is a kind of overview of Rob Bilott and the litigation against DuPont that kind of brought a lot of this to light. And so if you want kind of entertaining, it's a good kind of crime, law thriller type of movie. An entertaining way to get introduced to PFAS and what it is and where it is and kind of where we started with all of this. I highly recommend you go watch that movie. It's on Netflix, like I said. And then I do like to introduce the concept of parts per trillion. Maybe it's not something that we deal with on a regular basis. Other MCLs are in the parts per million or parts per billion range. This is a whole order of magnitude, 3 orders of magnitude lower that we're talking about parts per trillion. And so I like to just highlight that to demonstrate just how small of concentrations we really are dealing with when we talk about the parts per trillion or even low parts per trillion range. I got here 1 drop in 20 Olympic pools, or I like to say, a football stadium, a large, like SoFi Stadium, a large football stadium. If I hit a half a teaspoon of salt anywhere in that stadium, in the rafters, under any seat, in a suite or on the field, like, would you be able to go, how long would it take you to find that half a teaspoon of salt somewhere in that large football stadium? That's the type of concentrations we're talking about, and that we're regulating on, low parts per trillion, and that systems are going to have to comply with. So I like to just kind of put this in context of just how small these concentrations really are. So with that kind of baseline understanding of PFAS and what we're dealing with, let's look at kind of the history here briefly. We'll kind of blow through this, but I like to give some context around the regulatory history here. It's driven largely by the EPA's PFAS strategic roadmap. This is a roadmap that they laid out a number of years ago that they update. They kind of issue this annual progress report. The last one was in December of 23. They talk about what the EPA is doing, what actions they're taking, what regulations they're proposing to address PFAS impacts across the environment. And that includes water regulations like we're talking about today, PFAS MCLs, wastewater, biosolids, air emissions, anything and everything that PFAS impacts. And they've laid out this roadmap of how they plan to attack PFAS in all of these different areas to, like they say, research it, come up with analytical methods, restrict the use with product bans and substitutions, and then remediate it within the environment and the regulations that they lay out to do that. I like to highlight just a few of those here, and you'll see right there in the middle, those are the two biggies, I'll call them, the two big dominoes that fell recently, just 2 months ago now, early April. The PFAS MCLs for these 6 constituents, or the 5 constituents that have numeric MCLs, and then this 4 of those are which are rolled into a hazard index, and we'll talk about that. And then the other one is the CERCLA designation. This is more commonly known as the Superfund law. CERCLA designation of PFOA and PFOS as hazardous substances. And we'll talk briefly about what implications that may have. The third kind of biggie would be a RCRA designation, which EPA has proposed for up to 9 different PFAS constituents, a RCRA hazardous substance, hazardous waste designation. And that would have far-reaching implications about how people manage, in particular, treatment residuals. But we'll touch on that a bit. I link here the reference to EPA's website, their strategic roadmap. Feel free to read it at your leisure. But this is kind of where we are. This is something that started multiple years ago. We've now got 2 significant regulations finalized, the MCLs and the CERCLA designation. And this is going to have far-reaching impacts across multiple sectors and across the environment here over the years to come. With that, we'll talk about UCMR 5. If you want to go back to one of the previous webinars, I do a bit of a deeper dive into what UCMR 5 is and why and where we are. But suffice it to say, it's a program that the EPA has the Unregulated Contaminant Monitoring Rule, UCMR, and this is the 5th go-around, the 5th iteration of it, where they look at unregulated contaminants, in this case PFAS, 29 different PFAS compounds, analytes, that they're monitoring on a national scale, sampling drinking water systems, analyzing it with EPA-approved methods, analytical lab methods, to determine the prevalence and the concentrations at which these PFAS constituents exist within drinking water systems nationally. And so we're about a third of the way through that sampling effort, that national sampling effort, and it's a big effort. And what does that data tell us? The EPA has released or continues to release that data quarterly, and we're going to look at what the latest quarter or adding the latest quarter of data, what that tells us about the national picture of PFAS impacts. Like I said, this is as of April 2024, which is the latest release. And what we're talking about is a large percentage of public water systems nationally will be tested through this program. To date, about 30% of systems have been tested. So this is not by any means sampling of every public water system across the nation, but it is a good portion of systems. And what does that data tell us? What do we see? What concentrations are we seeing across the nation? We've got 25 some odd or 2,400 some odd small systems that have been sampled so far, and 2,400 large systems. So a good cross section of small systems and large systems. And what we're seeing is PFOA and PFOS, and the EPA expected this, as the dominant PFAS constituents that we're seeing detections for across the US. And in particular, detections above MCL values, which for PFOA and PFOS in particular, the adopted MCLs are 4.0 parts per trillion, 4 parts per trillion. So what I've done here is took a look at that data set, and what this is showing is PWSs, drinking water systems across the nation, that have at least one sample above that MCL. For PFOA, PFOS, and then these other 3 constituents that have numerical limits, although those numbers of systems are far less. But what it shows is that roughly 1 in 10 small systems have sampling results above PFAS MCLs. Now we'll talk about why that doesn't necessarily mean they're in violation of the MCL shortly here, but they do have at least one sample result that exceeds those MCLs, 1 in 10 small systems nationally and about 1 in 5 large systems. And so when you look at that entire data set, that says about 16% of systems nationally have tested and have results above these MCLs that were just recently finalized. Therefore, we could expect somewhere around 16% of drinking water systems to require some level of treatment or sourcing alternate water sources that comply with MCLs or that are below MCLs. But roughly 16% of systems should expect now or in the near future to have to do something about PFAS as a result of these PFAS MCLs. And this is what it looks like pictorially on a national basis. And this is through the EPA's PFAS analytic tools. You can go online. I provided the link. You can go and mess around with this and different filters on how to present this information. What it shows is all the white dots across the nation are systems that have sampled under the UCMR program that don't have detections or have detections that are below the reporting limits for the UCMR program. The yellow dots here are systems that have detections above those reporting limits, which in the case of PFOA and PFOS, those reporting limits are 4, which is also the MCL for those constituents. That's not the case for the other 3 numerical MCLs. And then the brown dots here are those systems that have detections, but maybe don't exceed the reporting limits here. So what I like to show this for is to show that it is a national problem. Yeah, it's centered in urban areas, but that's not entirely the rule. There are rural areas that have PFAS impacts that are going to have to treat as well. So there's not one defining set of systems across the nation that you can point to say these are the ones that have a problem. This is a national issue, and it's going to require a national response. So what do we, I like to do these kind of break it up, recap slides, just because it's a lot that I'm throwing at you, I get it. What have we talked about so far? This is, the EPA strategic roadmap is this whole of government approach, regulating PFAS across all matrices, water, wastewater, air, soil, cleanup sites, all of that. The EPA is looking at how PFAS impacts all of that and how they're going to regulate all of that. So far, we've got the drinking water MCLs for sure that we got to deal with for drinking water systems. And those are the 2 key regulations, those drinking water MCLs and then the CERCLA designation as well, that's going to impact the remedial cleanup Superfund site designation that now comes into play, or existing Superfund sites that are going to now have to sample for PFAS and potentially change their remedial approach. And what are we talking about as a holistic impact? Somewhere between 10, 15, 20% of drinking water systems nationally are going to have to deal with PFAS in some way or another. So with that kind of setting the stage, let's take a little bit of a deeper dive into what those finalized MCLs are, and let's discuss a little bit about that. So how did we get here? I don't want to harp on this, just a little bit of a high level overview of the process that the EPA took to come to these finalized MCLs. And really the takeaway here is just, this has been a continual process for multiple years. This isn't something that the EPA just kind of pulled out of a hat and said, this feels good, let's go. They did a lot of sample collection, there's a lot of data, a lot of human health studies, a lot of economic analysis that went into and informed the finalized rule that was adopted in April. And that rule, the intent of it is to provide the highest level of human health protection possible that is defensible and that can be implemented and is not overly economically burdensome. And so what are those MCLs, those maximum contaminant levels, those enforceable standards? To date, we've kind of had this state-by-state patchwork. Some states maybe didn't do anything about PFAS in drinking water. Other states kind of took a proactive approach, and this is not an exhaustive list, but this is some of those states and the drinking water MCLs that they had adopted prior to the EPA adopting the federal drinking water MCLs. And so you'll see Massachusetts, that's a combined MCL, all those constituents combined above 20 or 15 or 13 or 10. You'll see kind of this teens range of MCLs. And then the EPA came with federal MCLs of 4.0 for PFOS, 4.0 for PFOA, 10, 10, 10 for PFNA, PFHXS, and GenX, and then 2000 for PFBS as part of a hazard index with those other three before it. What you see here is particularly for PFOS and PFOA, the EPA adopted a federal drinking water MCL significantly lower than even those other states had adopted prior. Those states now have 2 years from when EPA finalized the federal drinking water MCL to now adopt this new, lower, more stringent federal MCL. All states need to comply with it or be stricter than the federal drinking water MCL. So these states got some work to do to revise their rules, their state-specific MCLs to be at the federal MCLs or lower. And then any states that hadn't taken action to this point now need to adopt the federal MCLs and enforce those MCLs for drinking water systems within their state. And what is this hazard index I keep talking about? It's, you know, the first time this has been done for a drinking water MCL, so it may be new, it may be a little bit confusing. I admit sometimes it is confusing for me as well. But basically, EPA is regulating these 4 specific compounds because they have compounding human health effects when they are present as a mixture within drinking water. So if a human ingests a certain concentration of 2 or more of these compounds over their lifespan, then it has negative human health impacts, and therefore we need to regulate that. So it's this mixture idea of 2 or more. And you take this additive fraction or ratio of GenX, which is HFPO dimer acid, more commonly referred to as GenX, PFBS, PFNA, PFHXS. You take the individual results that you get back from your lab analysis over these denominators, add it together, and you compare that to the hazard index value of 1. And I clarify there that that's one significant figure, and I'm going to talk about what that means here. If it's above 1, then that's an MCL violation on a quarterly running annual average basis. If it's 1 or below, that's not an MCL exceedance. And so here's the EPA's example of those calculations. I won't go through all of them. The only thing that we added here is that 0.9, 2.7, 1.4, just demonstrating you take these results in example 1, 0 for GenX, 200 for PFBS, 4 for PFNA, and 4 for PFHXS. You take those results that you get back from the lab, put them over their individual denominators, add them together, and it's 0.9. And at the end, actually, the hazard index there should be 1, rounded up to 1 for one significant figure, is not an MCL exceedance. It does not exceed the hazard index of 1. In case number 3, it's 1.4. That gets rounded down to 1 at one significant figure. Again, not an MCL exceedance. But in the cases of 2 and 4, where they get rounded up to 3 and 2, those would be MCL exceedances if you continue to exceed 1 on an annual running average. And so what that means is if you're doing quarterly sampling and you have 4 quarters of results and your hazard index is 1 and 2 and 1 and 2, your average is going to be 1.5. That's in exceedance of the MCL of 1, and that's an MCL violation on that running annual average there. So it's not one specific instance that you exceed, but it's that annual average. And so what are the regulatory requirements that come from these MCLs that we just talked about? 4 parts per trillion, 4.0 parts per trillion, 2 significant figures there for PFOS and PFOA, and then the hazard index, and then PFHXS, PFNA, and Gen X each have numerical limits at 10, which were their denominators there in that hazard index, but they also have numerical MCLs of 10 parts per trillion each. What does the rule require, though, from drinking water systems? It requires that you analyze for PFAS. You monitor for PFAS, just like you do for any other constituent that has an MCL that you're required to report in your consumer confidence report. And they prescribe either EPA method 537.1 or 533. Both of these methods are acceptable. Both of them sample for all 6 constituents that have an MCL, and therefore you'd get the results that you need for compliance. There are small differences between these methodologies, and we won't dive into that here today. But suffice it to say, if you're going to go out and collect a sample, talk with your local lab. These are one of those 2 methods that you would utilize for your ongoing monitoring requirements. And what are those monitoring requirements? There's this nice, complicated, convoluted flow diagram that the EPA put together. In most cases, it's going to be quarterly sampling initially. The MCLs were adopted in April of 2024. Drinking water systems have 3 years to complete their initial monitoring period. That would be, in most cases, 4 quarterly samples for PFAS utilizing these EPA methods, 537.1 or 533. That initial monitoring period, again, you have 3 years, so by April 2027 to complete that initial monitoring, and that determines whether you need to take action based on those results. Take that annual average of those results, and if you're in exceedance of the MCLs, then you either need to treat or find alternative water sources to come into compliance with those MCLs. Now, this is the ongoing monitoring. After 2027, we then enter a period from 2027 on where drinking water systems need to monitor ongoing for these PFAS constituents. And that's what kind of this second level talks about. It defaults to quarterly monitoring, but if those results come back consistently low, say for your first 4 you get results below the MCLs, then you can move into annual monitoring. Unless those results come back in your 1 annual event above the MCLs, then you get kicked back into quarterly monitoring. But say you're doing annual monitoring and then you get 3 consecutive years below what they call these trigger levels, which are on the left, which are half of the MCLs. Basically, you're getting consistently low concentrations or non-detect concentrations. Then you can enter triennial, every 3-year sampling. Until and unless those results come back above MCLs, then you're kicked right back to quarterly monitoring. So you can kind of think of it as this default for quarterly monitoring. If you're consistently lower, then we can enter less burdensome monitoring requirements, less costly at annual or triennial, but default is quarterly monitoring. And as you go through that quarterly monitoring, we kind of talked about this, but what constitutes that MCL exceedance? If you have that quarterly running annual average, say you're in quarterly monitoring, your annual average of those results are above the MCL for PFOA or PFOS of 4.0, that's an MCL exceedance and that triggers action. Or if your annual average for these other three, PFHXS, PFNA, and GenX, which have numerical limits at 10 parts per trillion, if your annual average is above that, that's an MCL violation or an MCL exceedance and requires action. The other, and then again in the bottom right there, same thing for the hazard index that we talked about. The other nuance here in the top right is if at any point during your quarterly monitoring, say it's your first quarter that you're monitoring and your sample comes back at 4 times the MCL or above 4 times the MCL, say your next 3 come back at 0 or non-detect, that first sample on an average basis would still put you above that MCL. Even based on that first sample, you're immediately in exceedance of the MCL, no matter what the remaining samples are. The other case would be if you're in semi-annual monitoring. If your first one again is above 4.0, or if or say your first 2 quarters are above 2 times the MCL, basically at any point, if those results put you so far above the MCLs that no matter what your next samples come back at, you would be in exceedance, you're immediately in exceedance of that MCL. So that's one little nuance there to note within the rule. Then I touched on this, what's the implementation here? So within that first 3 years, we talked about that initial monitoring period, completing the 4 quarterly sampling events in most cases. You can utilize, if you have been participating in the UCMR 5 program, you can utilize UCMR 5 results to qualify for that initial monitoring period. Or if your state has state mandated sampling, typically that will be allowed to be used to qualify for that initial monitoring period. But within this first 3 years, we got to get going. We got to start sampling, start monitoring for PFAS and determining what that baseline level is. And then at 3 years, starting in 2027, then there are reporting requirements. So that point, 2027 and beyond, is when systems will have to start including the results of monitoring within their consumer confidence reports, and then start issuing public notification for violations not of the MCLs, but of any monitoring and testing procedure violations, say the wrong method was used. And then at 5 years, this is kind of, you can call this the compliance date, where in April of 2029, all drinking water systems need to comply with those PFAS MCLs, provide notification, public notification of any violations of those MCLs, and then take action. So this first 3 years is the initial monitoring period. Year 3 through 5 is the initial reporting period and ongoing monitoring period. And then after year 5 is the compliance period, if you want to think about it like that. I want to give one example, and this is what I advise to everyone I talk to about this, is don't wait. We've got 3 years. We've got till April 2027 to complete our initial monitoring, but there's no real reason to wait to complete that initial monitoring and determine if you have a PFAS problem that needs to be addressed. And the reason why is this timeline right here. So say we started proactively in April of 2024, let's start our quarterly sampling. We got a year of monitoring to do to determine if we're in compliance with those MCLs. Say those results come back above any one of those 5 numeric MCLs or the hazard index, and we're in violation, we got to start taking action. We got to treat, we got to go look for a different source. We got to drill a new well, put a well out of commission and go drill a new well, whatever that looks like to get back into compliance. But that planning period can take a number of months, even just to decide what you're going to do and what's the best course of action. And then say you decide, okay, we're going to put in wellhead treatment. All right, well, that design period can take anywhere from 3 to 9 months, or sometimes even longer, depending on the size and complexity of the system. Maybe you have to go out to RFP for an engineer to put that design together. And then once that design is complete, then maybe we have to go out to bid again to, procure someone, to a contractor to build that system. Not only that, once we have the contractor site, they have to go procure the materials. Carbon and ion exchange are effective treatment technologies, but they require steel pressure vessels, which could have a lead time anywhere from 3 to 12 months or longer. Or maybe you need a new transformer because you need a new booster pump. Transformers right now have 80-week lead time, a year and a half lead time. I mean, there's realities to equipment procurement for these treatment systems that extend that duration. And then we got to build the thing for 6 to 18 months, depending on the size. I mean, we keep going further and further out. We got 5 years to comply, but when you look at it in this way, that's not a lot of time to get things moving, to get them in action, to get funding for all of this put in place. So I always advise my clients, start acting now, start getting these things in motion. There's no reason to wait. Get the people on board that you need to make the right decisions and get the funding in the door. There's federal and litigation funding available to drinking water systems, and we'll touch on that. But there's no reason to wait. There's no reason to wait until those last 12 months of the first 3-year period to start sampling. I do want to note that, and this is not an excuse to procrastinate. I am a procrastinator myself. But again, this is not a reason to wait, but these are realities that sometimes the equipment can take a long time to procure. And so the EPA did recognize this. There were a lot of comments after the proposed regulation came out about how systems are going to comply and the timeline. And so the EPA recognizes they give an available extension that the Primacy Agency would grant for 2 additional years. So that's by April 2029, drinking water systems need to comply with these MCLs, have treatment in place if necessary to get below the MCLs by April of 2029. If those systems are moving towards putting in treatment, but say they have capital improvement expenditures, they don't have the funding available right away, or the treatment vessels are on order, but the lead time is 2 years now or 18 months because now there's 3,000 systems nationwide that are all vying for this same vessel that only a couple manufacturers make, or this particular media that there's only a couple manufacturers that produce, right? There's supply chain issues here. There's an option for 2 additional years of compliance extensions to move April 2029 to April 2031 if there are those supply chain and capital improvement realities. There are other extensions available for small and disadvantaged communities under the Safe Drinking Water Act. I put those section references there so you can go look those up. But again, not an excuse to procrastinate. This is just those extenuating circumstances that take into account that there will be a supply chain crunch. There's going to be 1,500 to 3,000 systems nationally within the same period that are all vying for the same vessels and the same media and the same transformers and the same valves and the same piping to put in these treatment systems or to drill new wells and put in wellhead treatment. This is why I keep saying, don't wait, act now, especially on the funding side. That funding, federal funding, will dry up. There's no reason to wait to submit for that. We'll touch a bit on primacy requirements here. Half the audience here are state regulators or regulators of some kind. So this is particularly appropriate for you. There are additional requirements that you may already be familiar with enforcing other drinking water MCLs. There may be some nuances here with PFAS that you should be aware of. But again, most of this should be familiar to you. Those states that have state-specific MCLs got 2 years to adopt the federal MCLs or more stringent. Start the enforcement again after the 5-year period. All of the consumer confidence report and reporting requirements and all of that comes into play after year 3 and into year 5, and then the compliance. 2 things I highlighted here, though, are those variances and exemptions that we talked about, and then emergency planning as well. State agencies, this may require additional knowledge about PFAS concerns that aren't necessarily typical for other drinking water constituents of concern. And so those are things to look at. I provided the section within the federal drinking water MCL rule that the EPA published. So you can go and look at those, or if you have questions, please feel free to reach out to me or type them in the question here and we can go through that. I'm not going to touch on all of it, but I just want to say there are certain things within the primacy requirements, the enforcement requirements, that may look and feel a little bit different for PFAS than for other constituents. Hang tight, we're almost there. Stay with me. If you've fallen asleep, wake back up here. I just want to touch on this briefly for any wastewater folks out there. I know we're talking about drinking water MCLs today. Stay with me. The reason I bring this up is because the reality that drinking water MCLs are kind of the first step, and they inform other water quality standards and other enforceable levels, whether that be a water quality standard, like I said, or an MPDS discharge limit for municipal wastewater treatment plants. The drinking water MCL is the first step, or the MCLGs. Those inform surface water quality standards, which then inform the MPDS discharge limits that these treatment systems have to comply with. And where that goes potentially for some wastewater systems, and this is kind of what I want to touch on, is some systems, some treatment plants nationally may have to face the reality of putting in treatment at the treatment plant on a municipal level if sampling and characterization within the collection system and industries and residential contributions demonstrates that enforcement within the pretreatment program alone will not get your effluent concentrations below MPDS discharge limits. This would be if you have high residential contributions of PFAS to the treatment plant. That may push you into the reality of potential treatment at the municipal level, which is just a whole nother webinar, a whole nother discussion, and a whole nother level of complexity way above and beyond that of treating PFAS within drinking water systems. So that was a ton. I probably should have put a second recap slide in there, but for those of you that got lost, time to come back. Let's talk about what we learned here. We now have federal drinking water MCLs. States may have their own specific MCLs. Talk to your state about what those may be. It may be above and beyond the 6 constituents that the EPA is regulating within federal MCLs. We talked about what those MCLs are for PFOA, PFOS, and the other 4. The other 4 regulated as this hazard index, this mixture of PFAS soup, if you will, and then the numerical limits for those 5 PFAS constituents. We talked about what those monitoring requirements are, this concept of the running annual average or quarterly running annual average, where you average those results across a year, and that is what you compare to the MCLs to determine if you're in violation. We talked briefly on this trigger rule, but this idea of decreased monitoring requirements if your concentrations continue to come back relatively low or below these trigger levels. And then I just want to emphasize again, to act now, the timeline may seem long, 2029 may seem like a ways out, but believe me, it's going to be here before we know it. It's not a long time for those who maybe are familiar with capital improvement projects, which CIP plans are often at least 5 years out, to get funding, to put in treatment, to build the treatment, to deal with all the supply chain issues. It's time to act now and start planning and characterizing and determining what your next steps are going to be. What are those funding options available? Like I said, you know, this may be a significant cost for many systems out there, small systems in particular. And one of my previous webinars you can go look at, and I provide some cost curves of what a typical granulated activated carbon treatment system may cost based on flow, or what a ion exchange system may cost based on flow. You can go look back at that, but you know, anywhere from $500,000 to $5 million, depending on the sizes of the system, or maybe even more for some central plants that we're talking about to implement treatment here, or the cost of drilling a new well that you're not certain will have PFAS or not. It may not be a better situation. So those are real dollars. Those are realities for a lot of us out there. There are funding options available. The federal government recognized this in the bipartisan infrastructure law, the bill law. There's $4 billion allocated through SRF, the state revolving fund. 25% of that, a quarter of that, $1 billion is earmarked for disadvantaged communities or smaller drinking water systems. So there are funds through SRF available, $4 billion worth. $5 billion of that is grant-like funds rather than low interest loans for, again, small and disadvantaged communities here. $2 billion of that has already been appropriated and is available already. Some of that's set aside for tribal governments, but small and disadvantaged communities, there's grant funding available to help offset the costs of these treatment systems. I provided a link here to some of that. And then also when the EPA finalized this rule, they announced an additional $1 billion available to private well owners to deal with the impacts of PFAS MCLs. There may be other funding options available, such as cost recovery through litigation. There's the large class action settlement, nationwide class action settlement. If you're not familiar, go to that link there, the PFASwatersettlement.com. I made headlines about, in particular, 3M and DuPont and their settlement. 3M agreeing to a $10.5 billion settlement, or up to $12.5 billion, to offset costs for public drinking water systems. This is any public drinking water system nationally that has PFAS or has to sample for PFAS, which would be every drinking water system. And you can go to that website, you can go to the documents. They have a table that estimates the cost allocation based on your flow and your PFAS sampling results. So there's a significant bump if you're above the MCL of 4 for, say, PFOS or PFOA, where even at lower flows, that's something like $500,000 or $1 million from the 3M side of things. DuPont, Tyco, and BASF have also settled for a total settlement of about $12 billion against what many estimate is going to require $80 to $100 billion of capital expenditures to comply with this MCL. So it's not everything, but it's a good portion of it. It's 10% of the total cost here available through this class action settlement. And then, as always, you know, reach out to the EFC. They have resources available. That one down there at the bottom is a little info sheet that we did last month, the EC did with EFC. That's already out of date because the Tyco and BASF settlements have been announced since we issued that. So we'll have to update that. But there's funding options available. please leverage the EFCN and EEC if you have any questions as well of how to pursue and obtain funding to offset these costs. But overall recap, this is the last slide here, and then we'll get into some Q&A. Overall recap, we've got 5 PFAS constituents with numerical MCLs, PFOA and PFOS at 4.0, and then PFHXS, PFNA, and GenX, HPFO dimer acid, with numerical MCLs of 10 parts per trillion. We have a hazard index for those other 4. That's those other 3 at 10 plus PFBS. And that's that mixture with the denominators there that we add up the sum of the ratios, compare it to 1 as a single significant figure. So we've got 2 different kind of mindsets, the hazard index and the numerical MCLs to deal with. And then you may have other state MCLs for other constituents. So I don't want to focus solely on the federal MCLs. You may have state-specific MCLs to comply with. We've got that running annual average for the sampling and the monitoring. We've got that trigger rule that decreases our monitoring frequency from quarterly to annual to triennial. And then we talked a bit about those primacy requirements. And then again, just reiterating, act now. You've got everybody vying for the same treatment technologies over the next 5 years to compete with. You've got a limited amount of funding to compete with. So act now, start planning, start seeking funding, start implementing design and planning and design and procurement of these treatment systems if you already know that you have PFAS impacts, and seek, the additional experts to advise you on what's the best way to go. And that may be reaching out to your local EFCN chapter to ask for assistance, technical assistance or educational assistance, or shameless plug here, reaching out to EEC or a similar consultant to advise you on how to move forward to stay in compliance here. So with that, we'll move into this Q&A. Kristen, do we have any questions coming through here?
We do have a couple of questions, and thank you so much, Will. So just a reminder, go ahead and get your questions in if you do have any or comments, and I'll go ahead and start from the top. So first one is, are the sources of these PFAS and PFOS, et cetera, identified for small drinking water systems?
It depends. There's a bit known about sources, but it really depends. It's site specific. So you may have an industry that would be a local source, or you may have contaminated groundwater aquifer that is your source, and that may be a much bigger deal to deal with. So typical sources would be contaminated sites. That may be sites that previously had manufactured PFAS constituents. It may be fire training centers, landfill and landfill leachate systems, public sewer systems, wastewater treatment plants are a significant source to the environment. They're a passive source, but they are a source. And if they discharge to a drinking water source, then that may be the source within a drinking water system, is actually the wastewater treatment plant effluent. So it varies. A lot of these sources are known generally. It would take characterization and source identification to determine what your specific source is and how to mitigate that source.
Great, thank you, Will. And the next, it's not really a question, it's more of a comment. They said that they noticed on the compliance extension slide, they just wanted to note that variances and exemptions are not available in all US states.
Yes, thank you for that. Again, reach out to your state regulators. A lot of this can be state specific. I'm trying to provide, the best national information. But yes, a lot of this may be state specific.
Yes, thank you. And the next question, if funding options are not available, will the cost fall on the water or wastewater customers?
Typically, yes. This is a cost that needs to be incurred to comply with federal regulations, and that cost may be passed down to the ratepayers, the drinking water receivers, the public at large, through rate increases. Typically, is what you would see if there's not funding available to offset those costs.
Great. And then the next question is regarding funding options. It says the major sources of funding like bill funding and WIN Act funding may not be there by the time that PFAS treatment needs to happen. We certainly need more funding, especially for small systems. Do you have any thoughts on that?
I agree. I hear similar input from a lot of people across the nation. Is there's some funding available, but it's not enough. And a lot of the comments submitted after the EPA proposed the rule and before they finalized the rule, that public comment period, that was what a lot of the comments were saying, is we need additional funding. There's continual lobbying going on to the federal government to try to allocate additional funds to deal with this. And that's all just around drinking water compliance. That's not even touching on what's going to happen in the world of wastewater, which those costs, if the regulations are adopted and kind of follow the same course of very strict regulatory requirements and limits, the costs of wastewater compliance may dwarf that of drinking water compliance. And so I don't have a good answer. Yes, more funding needs to be available. Where are those sources going to come from? If it's not from the ratepayers, if it's not from industry and manufacturers of PFAS chemicals, then the last source left would be the federal government. And like I said, I know there's lobbying efforts. We'll see how successful they are and see if there's additional funding in the offing. But for now, this is what we've got available.
Mm-hmm. And the next question is on health impacts. They want to know what the impacts are on people who consume the chemical. And I pulled up kind of a summary on the EPA's website. I'm going to drop that in the chat if you'd like to check that out.
Yeah, so like I mentioned, the EPA based these regulations on a large set of available information. That's animal toxicity studies as well as human health studies. There's been extensive biomonitoring going on for many years or even decades in a couple cases that inform this and that define what those negative human health outcomes are based on chronic and lifetime PFAS exposure. And so that's anywhere from birth defects like lower birth rate or impacts to a pregnant mother as well, or certain cancer impacts or decreased vaccine uptake in children is one of particular concern that drove kind of these lower concentrations, lower MCL goals. So there's a lot of studies. You can kind of read what the EPA has informed their decision upon. There's a lot of human health studies around PFAS exposure. There's more every day being published. There's a lot of ongoing studies, even the federal government pursuing some of those studies on a national scale to determine what are the health impacts from PFAS exposure across a lifetime.
Mm-hmm. Great, thank you. And the next question is, how long will the states have to adopt standards reflecting the drinking water MCLs?
24 months, 2 years from April 10th. So April 10th of 2026, states have to adopt those stricter federal MCLs.
And the next question is regarding the class action settlement. It says there was a phase 1 date of 7/12/24. What does that date represent?
Yeah, that's a good question. So that settlement and the allocation of funds to the class parties, which would be any public drinking water system that hasn't opted out of it, and the date to opt out has already passed. So there are two phases. There's phase 1 and phase 2 of allocating that $12 billion. The phase 1 parties would be those that had PFAS detections within their system prior to the settlement date. Don't quote me on it, but I believe that was June 22nd, 2023. It's on the website. So if there was demonstrated concentrations of PFAS within your system prior to that settlement date that is on the website, you have until that July date to file your claim to be within that phase 1 allocation of funds. Otherwise, and this would be the vast majority of systems that are only starting to find out that they have impacts through UCMR sampling or through the initial monitoring period for the federal MCL compliance. The vast majority of systems, that date to establish the impacts, again in 2023, is already passed. So you would only just now be finding out that you have a PFAS problem. So you'd fall under phase 2, and that submittal date is in 2026 to file your claim, July 31st, I believe, of 2026. So that phase 2 is just a second set of class action members. And the idea behind it is kind of this phasing out, a rolling out of fund allocation, because the $10 to $12 billion settlement for 3M in particular is roughly 20 to 25% of the market cap of the entire company of 3M. So there were concerns about insolvency of 3M and bankruptcy concerns, that funds may not be available, and cash flow concerns as well. So they kind of phased this out. Systems that already have established impacts and maybe you're already even planning for treatment, those would be phase 1 systems, and you have until July 12th to submit your claim form, and you can find that online, to submit for the funds available. And it's roughly half. I think it's $6 billion of the $10 billion is phase 1, and $4 billion of the $10 billion is phase 2. But then there's that additional $2 billion up to the ceiling of the settlement. So really phase 2 is $4 to $6 billion. So it's roughly half between phase 1 and phase 2, but it really has to do with when those funds are allocated and paid out, timeline wise.
Great, thank you, Will. And I did want to point out that I dropped a link in the chat to the class action settlement webpage if you're interested in checking that out. And next we have a comment. It says, it might be good to point out that MCL exceedances for PFNA, PFHXS, and GenX don't occur until 15 parts per trillion because they are rounded to one significant figure.
Yeah, this is, I debated whether to dive into that today, but I was hoping I'd get a chance in the Q&A to talk about this. Yeah, so for those three, PFHXS, PFNA, and HFPODA Gen X, they have numeric MCLs of 10, but 10 with one significant figure. So that means if your sample results come back at 11, that gets rounded down to 10. If it comes back at 12, 13, or 14, that gets rounded down to one significant figure at 10. If it's 15, that gets rounded up to 20. And so that would be an MCL violation. Again, if you're at the MCL limit, that's not a violation. It's in exceedance of those MCLs. So yes, you're correct. For those three, if your annual average is 10, 11, 12, 13, or 14, rounded down to 10, that's not an exceedance. It would be if your annual average comes back at 15 or higher, that would be an MCL exceedance. So thank you for the opportunity to explain that. Again, it's confusing, and these significant figures are going to come into effect. The EPA, I believe, currently has a calculator online for the hazard index calculation that does that significant figure adjustment for you. I didn't get a chance to check, but they promised that they would put a calculator for the numeric MCLs as well. And I hope that they do if they haven't already. And I hope that it does that significant figure adjustment so that we don't have to do it ourselves and confuse ourselves. We have a good federal resource to do that for us.
Great, yes, thank you for that comment. And next is a question regarding if you know anything about personal protective equipment for drinking water operators, if there will be any recommendations regarding the treatment of PFAS.
In short, I don't. There are many states that have issued sampling guidance documents that you can refer to that talk about the proper PPE equipment to where to protect the sampler, but also to limit or mitigate cross-contamination of the drinking water sample, say from a sampler wearing deodorant or fabric softener as a potential source of cross-contamination. So there are state guidance documents out there available. Look at your own state, or there are other states that have issued some really good guidance documents that do touch on what that PPE guidance is. I believe in the long term that would be driven by OSHA, and I have no knowledge of whether they are pursuing regulations or requirements or guidance around PPE protection for PFAS. So sorry, I can't help you further on that.
Thanks, Will. And the next question, well, they're asking for comments. They want to know if you have any commentary on the EPA risk assessment for PFOA and PFOS in biosolids.
Yeah, so the biosolids is going to be a big issue, or potentially a large issue. The CERCLA designation doesn't help. If there's a RCRA designation, that may complicate it further. I haven't reviewed in detail the EPA's risk assessment for that. I know that the EPA is aware of those risks and the potential that land application of PFAS-laden biosolids may have a horizon. You see it in the state of Maine has a statewide ban on biosolids application for biosolids with PFAS. It's become a big issue. Their landfills are starting to run out of capacity to accept biosolids. They issued a study recently that said that they need to open additional landfills or increase capacity at existing landfills, in large part because of the biosolids application ban. And that's one state. There's recently a bill proposed, I forget if it's in the Senate or not, that models after the Maine PFAS ban and proposes funding available if a national ban were to take place for biosolids applications across the US. So in short, it is a big issue. It is potentially a huge issue. I have not reviewed in detail the risk assessment, so I don't feel confident commentating on that specifically, but I do feel confident saying that the way regulations are going, or the way that they could go, it could become a very large issue nationally, and it's something worth tracking.
All right, I'm going to stick with the theme of asking you about your thoughts on things. Someone wants to know how you feel about the EPA going so low of 4 parts per trillion MCLs, much lower than any of the many states that have existing MCLs.
Yeah, I'll stay political with my response here, but I'll say that the EPA did establish an MCL goal specifically for PFOA and PFOS of 0. Basically saying that there is no exposure to PFAS that presents no risk to human health. So there's no safe level of exposure of PFOA or PFOS. So they set their MCL goal at 0. And then the MCL that they adopted at 4.0, for those two in particular, is as close as is feasible to the MCL goal when taking into account analytical limitations. And so that's the level that the EPA thought and felt most labs across the US could reliably detect down to the level of 4 parts per trillion, and therefore could be enforceable nationally, and that there would be enough laboratory capacity to analyze all of those samples that are going to be coming in. So my commentary would be that the EPA set those as restrictive as possible, which is within their right to do so, their mandate, and they recognized that there is no safe level of exposure to these PFAS chemicals. I'm not a toxicologist, so I won't provide my own opinion on exposure levels.
Well, thank you. We appreciate your opinion. All right, next question is, do you know if there have been any decisions made about the PFAS remaining in reactivated carbon under CERCLA?
So I don't believe that any final decisions have been made. The EPA released an updated guidance document on PFAS residual disposal and destruction options. And in summary, what the EPA recommends is for spent, say, carbon or spent ion exchange resin, the proper disposal of that would be at a hazardous waste landfill that has the proper leachate collection systems and liners to manage the leachate there, or incineration at a facility that burns hot enough and that has the proper permits in place. The reactivation process, there's a general acknowledgement, at least with those that I talk to, that again, there may be a horizon on reactivation of carbon. It has been demonstrated through pilot studies that reactivated carbon is still effective treatment and provides effective absorption capacity for, in particular, these 6 PFAS constituents. And so reactivated carbon is a useful treatment technology. It's that reactivation process that is the concern, and how to manage the emissions of potential emissions of PFAS to the environment through that reactivation process that is the concern. I don't know that the EPA has made a final determination on that. I don't believe that they have. I don't believe that it's currently restricted in any enforceable manner. But I do know that there is a concern about potential emissions through that process of reactivating in particular granulated activated carbon.
Great. And the next question is, do you know if there is funding for labs to purchase equipment and become certified to test for PFAS?
I don't know. That's a great one to start looking into. I'll, if you submit that question in the chat, then I'll get that report afterwards and I can look into that and respond to you on that once I know more. I've got a few people I can talk to that would know the answer, and I'll try to track that down for you.
All right, thanks, Will. Next question. If the limit is still 0, why are PFAS chemicals still being produced and used in food packaging?
So the goal is 0. The limit is 4 or 10. But yes, your point is well taken. There has been a ban on PFOA and PFOS production within the United States since the early 2000s. So the production of those specific PFAS chemicals in particular have been outlawed domestically. It still doesn't necessarily mitigate the import of products with those chemicals into the United States that are produced elsewhere throughout the globe. And then there's also the fact that manufacturers in large part moved away from PFOS and PFOA, which we would call the legacy PFAS constituents, into newer generations of PFAS chemistry, second and third generations of chemistry, replacement PFAS chemicals that may be some of what's currently regulated and many of which would not be constituents that are currently regulated. So they replaced it with different PFAS chemistry. Some of that would be considered what we call precursor PFAS constituents that ultimately in the environment may transform into some of these terminal compounds. So you continue to see legacy impacts and you continue to see PFOS and PFOA concentrations, even though the production of it's been outlawed for close to 2 decades now, in no small part because you've got precursor compounds that are transforming within the environment into these terminal compounds. So we've got replacement chemistry ongoing that continues to provide a lot of the very useful purposes of PFAS, which would be water resistance and oil resistance and fire retardancy, all of these things that are very useful that come from this fluorinated chemistry, but that are achieved with replacement PFAS chemistry that may not be currently regulated for a lot of those PFAS compounds, which there's on the order of 1 to 200 specific PFAS constituents that have been produced in any commercial way. And then there's thousands of theoretical or actual PFAS compounds, constituents, chemistry that could be produced that have some of those similar characteristics.
All right, we're getting down to the last few questions. So next we have, besides the US, are there other countries who are working to set up a monitoring for forever chemicals in treatment, or are others holding off or asking for exemptions?
Yeah, so, we're not always the leaders on these types of things. I would put Australia at the top of the list as far as timeline goes on monitoring and regulating PFAS. They were out in the front doing this before a lot of countries throughout the US. The European Union is also regulating PFAS as well as Canada. So we're not alone in this. Other countries, other areas of the globe are monitoring and are regulating PFAS in one way or another. I do believe, don't quote me on it, but I do believe the 4 parts per trillion for PFOA and PFOS are the most restrictive enforceable standards so far, though.
All right. And the last question that I am seeing, the chemicals of the hazard index are listed as unquantifiable exposure. So how does that differ from PFOS or PFOA?
A little bit out of my depth here as far as what constitutes unquantifiable exposure. I'll just leave it that the reason they regulate it as a hazard index is, from my understanding, is that health studies have demonstrated kind of cascading or magnifying impacts when exposed to two or more of these PFAS compounds that have similar negative human health impacts. And so if you are exposed to a mixture of these, it has kind of compounding effects. And so I'm guessing that's what they mean by non-quantifiable, rather than correlating a specific exposure of PFOS to a specific negative human health impact. But I'll admit I'm kind of guessing at that. But if you can reach out to me and we can have a continued conversation on that, I'd love to hear what you're thinking there.
And we just had a comment that came in. They're digging at your Dodgers. They said, "Go Phillies."
Well, yeah. Haters are gonna hate, but you can't argue with the championships though. So.
All right, and then last comment: Will Shaffer is an excellent presenter. Slides are just the right type and have contained the right information. Thank you so much.
Well, thank you. Thank you for having me. We're coming up to our time here. Thank you so much to the EFCN for hosting these, for inviting me to be able to present this information. Again, if you enjoyed this, there are 4 others within this series. Maybe you can skip the draft MCLs because this is kind of a refresh and update to that.
Mm-hmm.
But if you enjoyed this, please go to EFCN's website and go look at those past webinars. And like I said, there's a deep dive into treatment technologies. There's this deep dive into MCLs. There's a good overall kind of PFAS 101 high level discussion. And then, there's a couple other there. So I've done a few of these. I'm forgetting what they are already, but.
Well, and I actually dropped a link to the YouTube playlist in the chat as well. So if anyone wants to go check out previous webinars.
Yeah.
All right. Well, thank you so much, Will, for sharing your expertise with us today. Following this webinar, each of you will receive a follow-up email with the slides from today, as well as a link to the recording of this webinar. We ask that you please complete the webinar evaluation so you can let us know your thoughts on today's session. This helps us out with planning future webinars that are on topics that are important to you guys. Thank you so much. We hope to see you all at a future EFCN event. And thank you, Will.
Thank you. Have a great day.
Bye. Thanks.